An FFU is not a fan with a filter attached. It is a moving duty point inside a sealing system. If you select from open air maximum flow, the unit may miss airflow as soon as the real filter and casing are installed. The useful question is, can the complete FFU deliver the required module airflow through its full resistance range? Read the whole air path. Return air enters the unit, crosses any pre-filter, reaches the fan, passes the HEPA or ULPA filter, then leaves through the clean supply face. Every section changes pressure, sound, heat, access or flow distribution. The fan must be evaluated inside that complete boundary. Lock the project inputs before comparing products, module and sealing grid size, target module airflow, initial and final filter resistance, available external pressure, voltage, control method, sound limit and maintenance side. The room airflow concept and owner requirements define the target. There is no single face velocity value that is correct for every clean room. Convert room demand into module duty. For a defined coverage area, module airflow equals area multiplied by the project face velocity. Then decide how many modules are active and how the sealing coverage works. Do not stop at the average. Map velocity across the filter face, because two units with the same total airflow can produce very different uniformity. Next, build a pressure ledger at the same airflow. Include the pre-filter, clean HEPA or ULPA resistance, casing and discharge components, plus every project-specific external loss. Filter pressure alone is not the fan duty. A defensible selection states the complete test boundary and the configuration behind each number. Now move the clock forward. As the filter loads, resistance rises. The system curve becomes steeper and the operating point moves. Define both the clean filter duty and the loaded filter endpoint. A unit that barely reaches the clean point may lose airflow, increase speed, exceed power or become too loud before the planned filter change threshold. Plot both endpoints on the actual fan performance envelope. Check that the selected speed range reaches each point without crossing motor input, electronics, temperature, or stable operation limits. Do not use diameter, maximum airflow, or motor watts as a substitute for the curve. The intersection of the fan curve and each system curve is what the installed unit will attempt to deliver. Then examine the whole FFU array. Confirm how speed is commanded, what feedback is available, what happens on a fault and how the building or cleanroom control system responds. At the proposed operating points, verify electrical input, heat added to the space and sound. Never promise a protocol or control feature until the exact model and interface are confirmed. Maintenance changes the choice too. Define topside or roomside access, filter replacement direction, lifting space, gasket inspection, and how a failed unit is isolated. A design that works on a curve but cannot be safely serviced above a pack ceiling is not a complete selection. Finally, commission the assembled unit and the installed sealing. Depending on the project, that can include airflow, face velocity uniformity, filter integrity or leakage testing, sound, power, control response and alarm behavior. ISO 14644-3 provides cleanroom test methods, while ISTR PCC 036.1 defines comparable FFU performance tests. Match the final plan to the owner specification and applicable requirements. Want a defensible FFU selection? Send the module size, target airflow, clean and loaded pressure, voltage and control, sound target and maintenance side. Longwell can review the duty boundary before the fan and FFU configuration are frozen.